This is a video lecture for Professor Erb's class. This is a lecture that's going to be taught to some engineering students who might be interested in material science. Okay, so what I will be talking about in this lecture is stress and strain and how these work in metals and ceramics. Okay, so stress. Stress is a force applied to a perpendicular area. So the formula that can be used to determine stress is force divided by area. Simple enough. The units would be newtons over meter squared. Strain. Strain is the new length subtracted by the initial length over the initial length, which pretty much just means that when we apply the stress to an object, when it changes, we want to see how much it's changed compared to the initial value. And the formula for that would be stress is equal to the new length subtracted by the initial length over the initial length. And usually that's given as a percentage. So why these are important things to know about material science? Well, if we want to have a good understanding of the mechanical properties of materials when we applied forces to them, this gives us a good basis. So when we apply stress and get strain, we notice these regimes, elastic and plastic. What does this mean? Well, in a stress versus strain graph for metals, we can see these two regimes. Where it's first linear and then it curves out. And the y-axis would be stress and the x-axis would be strain. So in this linear regime, this is the elastic regime, which pretty much means that as we apply stress to the metal, the length will start to change, or the properties will start to change. But within this regime, if we let go and bring down that stress back to zero, the structure will remain the same. So there's no actual change after we leave it alone. But in the plastic regime, when we pass this threshold, we change the atomic structure of the metal, and once we let go of the stress or whatever, it returns into a different shape. And then at this point, this is the tensile strength where the actual material breaks. So in a atomic structure picture, if this is our initial metal, this is what it looks like on the atomic scale. We start applying stress to it, we'll see that the atoms start to restructure as we apply stress. And then once we pass this threshold, we actually see a change in the structure, which would be the plastic deformation. And then once we go even farther, the actual material breaks. And it remains in that plastic structure, and we have two pieces now. In ceramics, on our graph, we just have an elastic regime. This is because ceramics don't like to be restructured and are very brittle, so they won't change at all. So in the microstructure, we can have this same initial atomic structure, but as we change it, and if we just apply a little bit of change, then it will break but remain in its same initial structure. And that's the pure basics of stress and strain in material science. Hope you liked the video.